Hello, ladies and gentlemen. We're working on our homework for section 8.3, which was inverse sine, inverse cosine, and inverse tangent. We're just going to do a couple of these problems because they are straight to your calculator, and I don't think that this is a big deal for most people. So we're going to call up the calculator, and because I can see these problems, let's do them. So I'm going to come into my trig functions, and I'm going to toggle over to tangent inverse. Tangent inverse, I'm going to hit in 1. So I find out that the tangent inverse of 1 is the 45-degree angle. So what that means is if I took the tangent of 45, my answer would be 1. All right, how about cosine inverse of number 29 is 0.8, so I'm going to hit enter. So that tells me, and I'm rounding to the nearest degree, so I look at 0.8 and that rounds me up to 37. So this is approximately 37 degrees. Tangent inverse of 1.55. So trig functions, toggle over to tangent inverse, 1.55, enter. That tells me that, so what does that tell me? That says that if I type in tangent of 57 degrees, the answer will be 1.55. Let's see if that's true. So trig functions, tangent, 57 degrees, and I hit enter, and it's 1.539. So there's a little bit of a rounding error. We rounded when we put in 57 degrees, but for the most part, pretty much the same thing. So that's what we're finding out with these. All right, let us move on to the next section of problems. This says, find the unknown measures, round the lengths to the nearest hundredths, and the angle measures to the nearest degree. So I look at problem number 33, and for my triangles, I'm going to use A, B, and C. So A and B are sides, and C I will reserve for the hypotenuse when we need it. Angle L. Well, angle L is just, let's see, x plus 26 equals 90 degrees. This is going to tell me angle L equals x in this particular case. I'm going to subtract 26 from both sides, and that's going to tell me that x is 64 degrees. So that's that. The next thing that we need to do is figure out A and B. So because 26, I have confidence in that. I don't know if you heard my hesitation, but I'm a little bit worried about 64 degrees. Because I know for certain angle J, and I need to find out A and B. So I'm going to work with respect to angle J. So what do I know with respect to angle J? Well, I know the hypotenuse. And what do I need? Well, I need both the adjacent, that's the side labeled A, and the opposite, which is the side labeled B. And I can only work on one thing at a time, so I'm going to come over here and I'm going to do this. I'm going to work on the hypotenuse and the adjacent, and we will keep in mind that we are using the trig functions SOHCAHTOA. So which one of my trig functions uses hypotenuse and adjacent? Well, that's going to be cosine. So my cosine equals the opposite over the hypotenuse. So cosine of angle J is 26 degrees. The cosine of 26 degrees equals the adjacent over the hypotenuse. So A over the hypotenuse, which is 3.2. I'm going to multiply both sides by 3.2, and that's going to clear 3.2 from the denominator. I'm going to cancel both of those things out. So that means I have A equals 3.2 times cosine of 26 degrees, and I'm going to go to my calculator and type that in. 3.2 times cosine of 26. 3.2 times trig function, toggle over to cosine, and that was 26 degrees. Yep, just wanted to make certain, and I'm going to hit enter. So my answer is 2.876. That 6 is big enough to round the 7 to 8. So my answer is approximately 2.88. So A is approximately 2.88. From here, I have a feeling most of you are going to choose to use the Pythagorean theorem, and I'm fine with that. We can use any tool in our toolbox unless the directions specifically say you have to do it a certain way. So I'm going to say 2.88 squared plus b squared equals 3.2 squared. I want to make it easy for me when I go to my calculator, so I'm going to say b squared equals 3.2 squared minus 2.88 squared. It's neither here nor there that I'm doing it that way now. All right, so I'm going to move this out of the way so I can see what I'm doing. So I need to know what 3.2 squared minus 2.88 equals. Nope, I did it wrong. 3.2 squared minus 2.88 squared. My apologies. Gives me 1.9456. Well, I can round this and then take the square root, but that would give me an even less accurate number. So what I'm going to do is I'm going to say control square root, control over this little minus sign, it says ANS, which stands for answer. So if I hit that button, it plunks in the answer for me. And when I hit enter, it tells me that the square root of 1.9456 is 1.394. 4 is not big enough to round, so my answer for B is approximately 1.39. B is approximately 1.39. And A is 2.8. So we have found all three measures for number 33. We're going to look at number 44, or excuse me, 34, and I'm going to erase all of this stuff. For 34, I have the square root of 5, the square root of 2, and I need to know df. Let's just bang that out of the way. df is the hypotenuse. So the square root of 5 squared plus the square root of 2 squared equals c squared. The square root of 5 squared is 5. The square root of 2 squared is 2 equals c squared. C squared equals 7. I take the square root of both sides. C equals the square root of 7. All right, so we have that. I'm going to replace c with the square root of 7. And now I know all the side lengths, which means I can choose any angle and use any trigonometric function that I want to use. So I am going to randomly choose D because it's first in the alphabet. So with respect to D, I know the opposite, I know the adjacent, and I know the hypotenuse. So I'll tell you what I'm going to do. I'm going to do sine of D. I don't know what D is. That's what I'm looking for. Equals opposite over hypotenuse. The opposite is the square root of 2. The hypotenuse is the square root of 7. All right, I don't know what D is. I need to go to my calculator and ask my calculator which angle would give me the ratio of the square root of 2 over the square root of 7. So what I'm going to do is I'm going to rewrite this next line. Next line will say D equals sine inverse of the square root of 2 over the square root of 7. So that's what I need to go to my calculator and type in. Oh. So I'm going to do trig functions, sine inverse. And this is a little bit tricky. I haven't done it this way before, but I'm going to use this button right there. It's highlighted in red. For me, it allows me to put in a fraction. The very first thing that's highlighted is box over box. And if I hit enter, that's going to put in this box that I can then type in control square root 2, and I can arrow down and type in control square root of 7, and that makes certain that everything ends up where I want it to be. I'm going to hit enter, and that tells me that the inverse sine of the square root of 2 divided by the square root of 7 gives me 32.3 degrees. We are rounding to the nearest degree, so my answer for D is all right, I'm back. I had some technical difficulties. So D equals 32 degrees, and it's approximately equal to 32 degrees. So if I know that D is 32 degrees, all I have to do is say, what's 90 minus 32? And I'm going to borrow. So this is then 58 degrees. Okay. All right, looking at number 35. Erase everything. We have everything that we need, right? Yep, we did. We answered it. So looking at number 35, I know two sides and I need to know the third side. So let's go ahead and bang that out real quick. We'll call this B. We'll say 6.7 squared plus B squared equals 8.3 squared. I'm going to go to my calculator. No, I'm not. I lied. I'm going to do this just because it makes me happy to do everything at once. So B squared equals 8.3 squared minus 6.7 squared. And that tells me that B is 24, or excuse me, B squared is 24. I'm going to take the square root of both sides, and I'm going to use the square root of both sides because they're using decimals. That tells me it's okay to use decimals. The square root of 24 equals, no, that's not right. The square root of 24, why is it doing that? 24 is 4.89. So I'm going to say B equals 4.9. Okay. In fact, I'm going to go so far as to come over here, erase that B, and put in 4.9. Now I need to figure out angles P and R. I know all the sides, so I can use any trigonometric function that I want to. So I'm going to choose angle P just because it's first in the alphabet. There's no other reason than that. I can use any trigonometric ratio that I want. Because I haven't used cosine in a while, I'm going to say cosine of angle P equals, well, cosine is adjacent over hypotenuse. The adjacent side is 6.7 and the hypotenuse is 8.3. This is one of those ones I have to ask my calculator. Calculator, what angle would give me the ratio 6.7 divided by 3? And the way I do that is I say, the next line I'm going to write P equals cosine inverse of, in parentheses, 6.7 over 8.3. So I come to my calculator, I hit the trig function, I toggle over to cosine inverse, and I hit enter. I'm going to put in 6.7 divided by 8.3 and hit enter. This tells me that P is 36 degrees approximately. If I know that the measure of angle P is 36 degrees, then I can very easily determine that the measure of angle R, well, I'm going to come off to the side and say 90 minus 36. So the measure of angle R is 54 degrees, and there is all the information I needed to provide for number 35. Moving right along. 48. Boy, for such an easy looking problem, 3, 4, 5 is actually a little bit of work for us to do. So the first thing that I'm going to do is draw a sketch, because boy, I just feel more comfortable when I'm working with a sketch. So I think this is my right angle, my right triangle. Okay, So I'm going to come in and label things. Obviously 3 is my short side, 4 is my long leg, and 5 has to be my hypotenuse because the hypotenuse is always the longest thing. So I know that this is a 90-degree angle because it tells me that I'm working with a right triangle. So I need to figure out, we'll call it A and B. And again, just because, let's work alphabetically. I can use any trigonometric function that I want for A because I know all 3 sides. So I'm going to say cosine. Actually, we just did cosine. The one thing that we haven't done lately is tangent. So I'm going to say tangent of A would be, well, tangent is opposite over adjacent. So tangent of A is 4 divided by 3. I don't know what angle has a tangent of 4 divided by 3, and the way I'm going to type this into my calculator to find out is I'm going to say A equals tangent inverse of 4 divided by 3 in parentheses. So I come over to my calculator, I hit the trig function, I toggle over to tan inverse, I hit enter. I'm in parentheses, so I'm going to say 4 divided by 3 and hit enter. That tells me that an angle of 53 degrees. So the measure of angle A is 53 degrees. And if I know that the measure of angle A is 53 degrees, I can say that the measure of angle B is 90 minus 53, which means that the measure of angle B is approximately 37 degrees. Because I rounded this one, that means that this one isn't 100% exact either. All right, that's 48. 52, as part of an off-season training, the Houston Texans football team must sprint up a ramp with a 28% grade. To the nearest degree, what angle does this ramp make with the horizontal line? So let's draw ourselves a real quick sketch. And we're going to do this. And what this means, a 28% grade, it says that for every 100 feet we go this way, we go up 28 feet, okay? And it wants to know what the measure of this angle right here is, and I'm going to call that R because we're running up a ramp. So, and here's the thing, that ratio will stay the same, whether the ramp is 10 feet long or 200 feet long, that ratio is consistent. So I'm going to say that what I know, I need to think about what I know and what I need to know. And what I need to know is the measure of angle R. And with respect to the measure angle R, I know that 28 is the opposite and that 100 is the adjacent. And when I think about SOHCAHTOA, I immediately think tangent. Tangent is the one that requires us to know the opposite and the adjacent. So I say tangent of angle R equals the opposite, which is 28, over the adjacent, which is 100. So I go to my calculator and I say, calculator, tell me what angle has a ratio, has a tangent of 28 over 100. And I do that by saying tangent inverse of 28 over 100. So let's see, I'm going to come over and hit tangent or trig functions, toggle to tangent inverse, do 28 divided by 100 and hit enter. And that tells me that my ramp has an angle of 15.64. I'm going to round that and say that the measure of our angles, of our ramp's angle, is approximately 16 degrees. All right, 65, we're coming in the home stretch. This is the last of them. Which expression can be used to find the measure of angle A? And there was supposed to be a picture for this, so give me just a second to rectify. Okay, sorry about that, copy error. So I'm looking for the measure of angle A. I know all 3 things, so I can say that the cosine of A is the adjacent over the hypotenuse, so 3 over 5. I can say the sine of A is the opposite over the hypotenuse. So 4 over 5. Or I could say that the tangent of A is the opposite over the adjacent. So the opposite over the adjacent. The opposite over the adjacent. Sorry, I have to think out loud a little bit. So I look at these, and in order to figure out what A is, I would say that this is A equals cosine inverse of 3 over 5. So that's not, 3 divided by 5 is actually 0.6, I think. So it's not that one. If I did the same thing over here, I would say A equals sine inverse of 4 over 5. And my sine thing says 3 over 5, so it's not that one. And my tangent, I would say A equals tangent inverse of 4 over 3. 4 over 3, you might be tempted to say 0.75, but 4 over 3 is actually bigger than 1, 4 divided by 3. So that means that D is my winner. Thank you so much for watching. I hope it helped.